Preheating. The purpose of preheating is to reduce the cooling rate after welding, prevent the formation of cracks, and help minimize welding stress. The choice of preheating should be based on a combination of factors including the steel's composition, thickness, structural rigidity, joint type, welding materials, welding methods, and environmental conditions, and should be determined through weldability experiments. Heating range. Generally, the heat should be applied within a uniform zone on both sides of the groove, each extending 75 to 100 mm. The temperature measurement should be taken at the edge of this heated zone. For butt joints, the heating width on each side should not be less than 5 times the plate thickness. Post-heating after welding. Procedure. Immediately after welding, the weldment should be heated to 250 to 350 and held at this temperature for 2 to 6 hours. This process accelerates the escape of hydrogen from the weld metal, significantly reducing the hydrogen content in the weld and heat-affected zone, thereby preventing the formation of cold cracks. Post-weld heat treatment involves heating the entire weldment or specific sections, maintaining the temperature, and then cooling it in a furnace or in the air. This treatment method reduces residual welding stress, softens hardened areas, improves the structure and properties of the weld and heat-affected zone, and enhances the plasticity and toughness of the joint, thereby stabilizing the structural dimensions. Common PWHT methods. Overall heating treatment. The weldment is placed in a furnace for overall heating treatment, achieving satisfactory results. During the furnace entry and exit, the temperature should be below 300. Local heat treatment. For long-sized weldments that are inconvenient for overall treatment, but have a relatively regular shape, local treatment can be performed. PWHT considerations. For base metals with higher strength grades and a greater tendency to delayed cracking, such as ordinary low-alloy steel, pressure vessels and other welded structures operating at low temperatures, especially those used below the brittle transition temperature, components subjected to alternating loads requiring high fatigue strength, large pressure vessels, welded structures susceptible to stress corrosion and requiring stable geometric dimensions. After welding,